The topic of this letter is the physical property density. Density, which is given the initial D, is defined as the ratio of the mass of an object to its volume. Or put into mathematical form, density equals mass divided by volume. And if you remember way back in the algebra lectures, D equals mass divided by the volume is the same as A equals C over B. So if you know any two of the values, you can easily calculate the third. Mass is M, and it's an extensive property. Extensive properties depend upon how much of the material you have. Volume, V, is also an extensive property. But the really cool part is that density, which is mass divided by volume, is an intensive property. You can use this to help identify materials. It doesn't matter how much of the material you have, the density remains the same. We're going to need to know the units. For solids and liquids, density is usually, notice the term usually, not always, given in grams per milliliter or in grams per cubic centimeters, because milliliters equals cubic centimeters. For gases, the usual unit is grams per liter. So basically, density is mass divided by volume. Example, you have a penny from before 1982 when pennies were made out of pure copper. If the penny has a mass of 3.10 grams and a volume of 0.35 milliliters, what's the density of copper? Like with any problem, ask yourself, what do we know? We know the mass of the copper is 3.10 grams. We know the volume of the copper is 0.35 milliliters. We also know that density is mass divided by volume. Do we have enough information? Yes. We have 2 out of the 3 values. We have mass and volume. So now we can just plug and chug. Density is 3.10 grams divided by 0.35 milliliters. The answer needs to have 2 significant figures. 3.10 grams has 3 significant figures. 0.35 has 2 significant figures, and you go with the least number of significant figures. When you plug this into your calculator, you should get 8.857142857 grams per milliliter, which I think you would all agree has more than 2 significant figures, and so it rounds to 8.9 grams per milliliter. Example 2 of how to use this equation. You've got 15.25 grams of silver. You're given the density of silver. What is the volume? What do we know? We know the mass of silver is 15.25 grams. We know the density of silver is 10.5 grams. Once again, density is mass divided by volume. So plug the values in. You get 10.5 grams per milliliter equals 15.25 grams over V. We're going to do this in a very stepwise fashion. So here's the initial equation. Multiply both sides by V, which eliminates the V on the right-hand side of the equal sign. So you're left with 10.5 grams per milliliter times volume equals 15.25 grams. Now divide both sides by 10.5 grams per milliliter. That will cancel out the 10.5 grams per milliliter on the left-hand side of the equation. Now you have volume equals 1.45238 milliliters. But the answer should have 3 significant figures. You should be able to figure out why that is on your own. So the final answer is 1.45 milliliters. Example 3, and this is the first example where I'm going to have you do it before I give you the answer. You got a shiny yellow coin. It weighs 215.3 grams. The volume of the coin is 10.16 milliliters. What is the density of the coin? Now stop and do it out and come back. The correct answer is 19.29 grams per milliliter. This is how you got it. We know the mass of the coin. We know the volume of the coin. We know that density is mass divided by volume. We plug the values in. You see that this is the number you get on your calculator. But because 215.3 grams and 10.16 milliliters both have 4 significant figures, The final answer should have 4 significant figures. So you have 21.19 grams per milliliter as the answer. Could this be a pure gold coin? It's got the right color. We look it up and we see that gold has a density of 19.30 grams per milliliter. Our coin has a density of 21.19 grams per milliliter. Density is an intensive property, so all samples of pure gold will have the same density. It's pretty obvious that 19.30 grams per milliliter does not equal 21.19 grams per milliliter. You do not have a pure gold coin. Example 4. You have hexanol, 125 milliliters of the stuff, as a matter of fact. You're given the density. What's the mass of the hexanol you have? I'm going to give you a couple of seconds and then come back with the answer. Here is the correct answer. You know the volume. You've got the density. You know the equation. Density is mass divided by volume. Plug the values in. Multiply both sides by 125 milliliters, so it cancels out on the right-hand side. You've got 104.025 grams equals the mass. 4 significant figures. And so 104.0 grams is the mass. Last example. 45.05 grams of mercury has what volume? The density is 13.5 grams per milliliter. Do it out, and then I'll give you the answer. 3.34 milliliters is the answer you should have gotten. We'll run through it in excruciating detail. Once again, you know the mass. You know the density. You know the formula. You plug things in. Multiply both sides by volume so that it cancels out on the right-hand side. That leaves you with this equation. Divide both sides by 13.5 grams per milliliter so it cancels out on the left-hand side. You're left with this, but you should only have 3 significant figures, and therefore you get 3.34 milliliters as your answer. So density is simply mass divided by volume. If you know any 2 of those values, you can now calculate the third. So now you should understand density. Do remember it's an intensive property. You can use it to identify or help identify materials. It does not depend upon how much material you have, and we will be going on to other topics in the next set of lectures that deal with mixtures, pure substances, etc.